How's it going, everyone? Eulier Gonzalez again here, looking at the React Performance, which is a course taught by Steve Kinney, head front-end engineer at Temporal, this open source tool that is a durable execution platform, pretty much like Kubernetes, but to cover specific business use cases like Vercel, for example, is one of the company that is using that tool. So the goal of today's video is to not only make a quick recap of what we have learned so far in the Learn section from the React docs, but also dive deep into what we really care, which is the aspect of you might not need an effect, especially the escape hatches, that you might not need an effect, the life cycle of reactive effects, as well as separating events from events. So the point of this course taught by Steve is to learn how to write components in the most React components in the most performance way. So therefore you will write is performant React applications. So when you're going to provide these tools to other to your clients, you will know how to do that and what are the things that you need to do behind the scenes. So this is one. And we also look at what are the specific goals and what are skills a company are looking for. I'm not going to dive deep into much. Just only to briefly describe is what we have saw or what I have saw so far here in the introduction, React rendering, reducing rendering, especially these two topics, and then finally jump into the escape hatches. So the TLDR of this course is when it comes to performance in the context of React, not doing things is way much faster than doing it. And there's some corollaries to that. So you have is doing things later is faster than doing it right now. And the thing here is that it goes and it relates to the reconciliation engine, the React Fiber, which is back in the React 16. So they lay out the foundation of how now the virtual DOM, this computer this computer concept that the idea here is to represent is the ideal UI of the it's to represent the ideal UI kept in memory and sync with the DOM. So this process is known as the reconciliation, and this is what allows this as a developers to write this React components or to interact with the React API in a declarative way, which means that you tell React which or what state you want your UI to be, and then React sync the DOM or match the DOM with that state. And I think this is something important because understand this particular mechanism, even though that they talk about a lot of concepts, especially the functional programming and other concepts like memoization and techniques like that. You can take a look at their docs, but the idea here is that in that specific article they mention is what are the features that enable now from React 16, which lay out the foundations, which is now in React 18, we are now capable of. So for example, is the ability to pause, resume, or stop a rendering or rendering prioritization. So for example, using rendering prioritization, use transition. Rendering prioritization is use defer value, or concurrent rendering, for example, using use transition, okay, as a way to now update the state without blocking the UI. And I will argue that that perhaps is sending that to the timer, okay, to the timer API, which is now exists on the server and and of course in the web, as a way to now delegate this task to the micro task queue. Again, to the task queue, because the micro task is from the promise. Perhaps the using behind the scenes is promise, because now this is another stack that you can add callback, okay, and then the event loop will say, all right, if the call stack is empty, now let me actually pass down that function to the JavaScript world, to the callback, so it can evaluate that. So, but once you understand now the inner mechanism of JavaScript and how that works and how it enables, for example, this concurrent mode, all right? After all, JavaScript is a single thread language, and the way of how they can achieve that is using these specific APIs provided by the environment, whether it's the browser or on the server, okay? But again, this is just to describe is briefly now the inner mechanism, okay? And what will be the possible tool that they're using as a way to not only refresh your concept in JavaScript, but also to now have an holistic view of what's going on down there. So, and I think that's quite beautiful. It's very, very interesting. And because, especially if you want to optimize something, you need to know how that works. So, that's one of the reasons why we're looking is at the React rendering here as a way to understand how the things work, the mechanism, okay? Pretty much like you have a motorcycle, at least you need some basic knowledge of how, for example, the clutch work, the brakes, when you hit the accelerator, the wheels, the transmissions, the electrical system. At least you must know how the things work and how they combine each other. And when you're figuring out, oh my God, it's quite. It's like unlocking a new. It's like unlocking a new power, or if, for example, I don't know if any of you have a son or a kid or an uncle. I don't know if any of you have a son or a cousin or someone younger than you in your family, 4 years old, and when they describe or discover something, it's like, that's right. That's the aha moment. So, but in any case, here we are looking now at the Learn React, especially this section as a way to briefly describe all of this topic and then finally reach to this. So, because after all, React is a JavaScript framework that allows us to create or describe our UI using JavaScript functions. We look at how can we import those functions, export them, how can we pass or how can we now use JSX as a way to represent those components using JavaScript and HTML, and how you can connect that using curly braces, how you can now pass down props as these components, conditional rendering, list rendering, how useful is the key as a way to notify React, hey, I want you to keep track of this for me. And also is the importance of writing your React components in a pure way. Why is that? Because React describes the benefits of the ability to run this code in any JavaScript environments. For example, in the server, when you receive is an input, you will always get the same output. In other words, if you want to serve now these components giving a particular data, you always return that same output and send that to dozens of hundreds of millions of users, right? Also, you have now the ability to catch computation using the React built-in tools as well. And you can safely stop the execution when the rendering needs to stop suddenly. And this rendering is now the way how your components, or how you view your components as the tree data structure. So you have now the render tree, which is useful to understand in terms of performance, as well as data flow, and the dependency tree, as a way as what is the reusable logic that you're sharing across different components, as a way to bring interactivity. And this interactivity is a way of how now we make our UIs responsive, because otherwise we're just only writing is simple plain HTML with just with more jargon, with more code. So the way how you can add that is attaching is by creating a function and attaching that to an event listener using the curly braces. And if you want to now show data, which is the vast majority of applications actually are useful, okay? For example, you want to show is how much you send to your mom. Let's say you want to send $10 to your mom, balance to her balance account. In doing so, well, you also, once you do that, you want to see that data updated. So that's why we have now states, which is a components memory. So this is the way of how you can now show this data, and also edit when you want to update that. You need to do that inside of your event handler most of the time. And when you do that, now React passes through this rendering mechanism, pretty much like an assembly line. When you have is a motorcycle assembly lines, or a Ford assembly line, or also the hated the hated but needed assembly line for processed meat. Again, that brings us here. That particular process is one of that collaborate that we can now actually here having this conversation. But in any case, so this process is made of three phases. You get the trigger, the rendering, and the commit. So the first, it's a when this state update, it was caused at the root element, or it was caused it was caused at the root element, okay, or it was caused by a component or any of its ancestors. So the idea of that is that on the rendering phase, which is just a fancy name to say that now React is evaluating those functions, or if that happened at the initial root element, what it's going to do is to create all of these elements for us, and using the React create all element. If this was caused by a re-rendering, React will call that component that trigger that state updates, compute the props, the states, the event handlers, store that to be used in the next phase, and the output of that, which is a JSX, if that contains more React components, React will call that and repeat that process until there is no more component in a recursive way. So now that it finally reached to the commit phase, and when the React is now building or recreating during the re-rendering phase is when the VDOM recreation happens. And as I mentioned before, what actually the VDOM is doing is that is a programming concept that represents the ideal UI of the yeah that represents the ideal UI keep in memory and sync with the real DOM. And this process is known as the reconciliation. All right. And the using is the diffing algorithm, and now from React 16 is using the React Fiber, which is this reconciliation engine. All right. That provides some of the features that I already mentioned before. Okay. In the commit phase is when now React is going to apply those changes, which means if this was caused by an initial render, React will now append all of these elements that was previously created in the render phase to the DOM, and now you can see that. The other is when it was caused by a re-rendering, React will only apply the necessary bare minimum change and then update or sync the DOM with the VDOM, right? Once that happens, the browser detects those changes and then paint your screen and then paint your UI. So this process, which is a mechanical process that's going on every single time, okay, is something important to understand that completely from the React perspective and then from the developer perspective, which is something that we're going to talk. I also look at any time that you are now updating an state or setting an state, this act, the state act as a snapshot, which means that during the rendering phase, your state value of so the variable, the state value of the variable state updates will be reflect in the next render. And when you want to set your state, which is inside of the event handler, you can think that React fix that state for you. And also, for example, if you want to work with previous states known as batching, you can pass an arrow function inside of your event handler as a way to now send series of state updates by working with the previous state. Why this is useful? For example, if your event handler needs to update things asynchronous, okay, and that's something that we're going to talk about that with side effects. But in any case, that exists. This is important to recognize that. And then we also look at how can we update our objects in a state, update array in a state. The TLDR is that always return a new state, okay? And how you can use IMER for maintain the update syntax consists by having this mutable syntax, pretty much like JavaScript actually works. Okay. And when it comes to update your arrays, well, you can generate a new array or a new item by using the spread operator with the previous state of your array, and then you're going to now encapsulate that into a into square brackets and passes the new elements to that as an object, whether it's at the bottom or at the top, like if I like in a stack or as a queue, okay. As well as you can also now add some transformation to each one of those elements or remove elements from that using the filter. And this is something interesting because now when you started to work with these components, okay, and with the states and the objects and array, which is the basic uh, yeah, which is the basic data structure that most of the time we're gonna use uh, for any business. Okay. Then we look at how can we now scale or managing our states. Okay. So now that we know how to update our state in a component as a way to show data, uh, and how can we now show collections of data like that, how can we now manage our state? So for example, how can we structure our states? How can we keep this update syntax maintainable? As well as how can we pass data to distinct components? So first thing first, we need to understand how to think the UI state as state change. You know? Sorry. Ooh. Okay. Okay. How to think state updates. All right. It's like how to think state updates as, yeah, how to think UI state or UI change as state change, because things now we are shifting our paradigm. Instead of actually us manually to manipulate the DOM and its attributes and the event handlers, is now thanks to the React API we can do that in a declarative way, which means that we need to identify all the different visual states, uh, determine what triggered those state updates, okay, represent those states using the use states in memory, and avoid any non-essential states. And lastly, is uh, connect the state, or yeah, connect the event handler to set the state. This particular phase, or this 5 phase, which is something that perhaps is something that is based off the foundation of how you're gonna write your UI. Okay, especially when you need to think, which is a borrowed concept from the UI designers, especially when you need to actually get this and elaborate that, create this UI. So this is instead of looking at this imperative approach, okay, now we're gonna see is using React is this declarative approach. Again, this is just a mental model that they share with us, and they say this is the way of how React actually build UI, and also some other libraries as well. So once we know how to think our UI change as state change, okay, you just only tell React, hey, I just want, this is the UI state that I want you to be. You are going to take care of how do you match that with the DOM, period. And even though we also look at, now that we know how to represent or how to think about the UI state as state change, okay, it's also important to know how to structure your state, because this is what's caused the vast majority of bugs. So now uh, the software community, the React community, actually adopt a concept from the database engineer, which is normalization. And they say, when you're going to organize your states, group them together, group related state together, avoid contradictory state, redundant state. If you can get this data from it is prop or from another state, do that. Or if you can compute that, You don't need an state. Um, avoid duplicate state because they are hard to keep sync, and uh, avoid deeply nested objects in your state. And by deeply nested object is just, after all, the correct way to say that is that object that is calling another object, which means that when you have an object that now has these nested objects, the reality is that those two are different objects, and this new object, or this nested object, is just pointing to a property on that object. So yeah, just as a way to understand how the things works behind the scenes. And also, now how, for example, okay, and then now, for example, when you need to actually share that state across different components, known as state lifting and state up, okay, which is something that you're gonna do a lot of the time. This is now the way of how you can thinking in React terms. Is that when you do that, first, something that even they mentioned, that you need to have the mock, the data. Once you have that, or at least a mock data. So once you have that, then you can break down your UI components into hierarchy. Then you can break the UI into hierarchy components, and also create a static version of that UI. After that, find the minimal but complete representation of your UI state, as I mentioned here. Okay, find the minimal but complete representation of the UI state, and for example, you can ask yourself, hey, is this data, is this remain unchanged over time? So that's not a state. Can you get this data from its props? That's not a state. Can you compute this data from its props or from its state? That's definitely not a state. So what's left is probably a state. So once you do that, so for example, list of product, this is an state. If you pass that as a props, of course, that is not a state. Search input is an state. Checkbox input is an state. So inputs, whether it's computer or human input, usually are states. Okay, and then once you find the minimal but complete representation of your UI state, now it is time for identify where this state will live or should live. Because once you do that, you now choosing which components owns this, which is this will become the source of truth of all of the other components. And when you do that, it's like, all right, there is a reason why other frameworks and popular tools like Redux actually now centralize that in a single store. And they say, well, instead of actually, because at the end of the day, React keep track the app state per at the position of the render tree, right? And make that available to all the subchildren, so you can have access to an state that you define in a child from its parent. And the way to do that is that by lifting that state up. So that's why instead of doing that, so they have now solutions like Redux, where they say, hey, let me now centralize all of this state here in one place. And if you want to do that, This is now the interface that you want. This is not the way of how you're going to uh, interact, or how you're going to update that, as a way to say, hey, um, mhm, mhm, as a way to say, hey, if you want to update this state, that'll be used across different components. So now the position of the state doesn't affect where it is, okay? Which is something that React behind the scenes actually do, and allow us is to, for example, reset the state or preserve the state, because React is now attached the state to a position in the render tree. If you have the same component at the same position in the render tree, React will preserve that state. If you have different components at the same position at the render tree, React will reset that state. If you want to preserve the state with the same component at the same position, you can either uh, render the component at a different position on the render tree, or add to a key value as a way to notify, hey, I want you to now store this, have a unique identifier here, and then anytime I call this component, I want you to reset that state with this data that I'm passing to this component, if you're passing some data. So the idea here is that, because now this is what React is doing behind the scenes, and when you need to use a state in a particular position on the render tree, and then you suddenly realize, hey, now this pattern needs to use is the state, and you have to lift the state up, and then you're figuring out, no, is the pattern that it needs to really use that. You know, what happened here is that there's a couple gotchas here. First, as you do that, then you will need to pass down data via props, known as props drilling. And the other is that your state update logic becomes quite hard to maintain, because now this particular state that start at the leaf render component is now able to is now needs to handle more inputs, or needs to react to more inputs. So as a way to solve the first problem, which is solve the this variety of inputs, we have now is reducers. So reducers here is saying, okay, because we need to find a way to keep our state update logic consist, thanks to the use reducer hook, when we pass now is the reducer function, which will contain is which is a function that takes an action, that take a state and an action, and perform based on that action, you perform a new state of that, so to notify to React to update that state. And also you can now have here, using a switch case, of course, you can now here is see how you can now update this state logic in a consistent way and in a maintainable way. And when it comes to actually, this is now how you can solve this, all right? Especially when you're starting to when a state needs to be shared across different components, okay, known as lifting a state up, okay. So now it needs to actually react to more inputs. Use reducer, which is also a concept from the reducer, okay, and that makes a lot of sense. That makes a ton of sense. The other is, all right, so how now you can do, for example, is handle this need to pass data through props, especially when you need to lift and stay up and up and up and up. So you are effectively are creating is a you are effectively creating is this change, and if any of these components at that position in the render tree remove, or you don't show that for any reason, you hide them, then you break that. So context now provides another centralized place where you can now share data, okay? And you might be tempting to overuse that. So we're going to explain how to use a context as a way to create a context in a file, export that context, and inside of that context, using the create context, you can put there is static data, or even states as well. For example, here create context. So the default value is something like this, but also you can is now create now more, or assign to those, exactly, or assign to those provider is now a hook. For example, use a state from that. So this context, after all, it just represents which context other components can use or provide that. So we look at, you need to create a context in that particular file, and then export that, of course, use that component, use that context when the component is needed, use context, and then provide that must be one top above the component. You can also provide the context at the same level as the component that is need to. It's fairly not that common, but you can do. But most of the time, the way of how you now send or provide that data, that context, is thanks or by putting is one level above to the component that is needed, at least. Putting the provider at least one level above the component, the needed component, the component that is the component that needs that. Okay, so with that, one of the caveats of using this is because React will re-render all the child components that use a particular context starting from the provider when the value change. And that might not be something that you want, especially if that provider function gets called every time that is needed or that is rendering that. So to save some computation times, or which is part of the optimizations, you can is defining there is some building techniques like Mimo, and as a way to save re-renderings or catch computations between re-rendering, and they use callback to catch computations between, or to catch functions reference between re-rendering. Okay, and why is that? Because when you now have this context, which is something that you must use for small app level data, for example, analytics, for example, authentication, theming, and when you find yourself in the need to deal with a lot of inputs, when you find yourself in the need of having a state here that needs to react to several inputs, which is when you combine with reducer and context. And that's why here, when you do that, you can only have much more predictability, unlike older version of context, which usually tends to actually be not that good, but now is fairly good. Okay. Again, for this small app level data, and the way to do that is by now creating is the context. You're gonna create the context for the state, also for the dispatch, which is the combination between the reducer and the context. You're also going to define is your reducer function, and export the function that you're going to use the state, the use reducer, and now provide is in the GSX the state and the dispatch, and attach the data and attach the value to each one of them. So now all of the components that actually make use of that, of course, you need to return is the children as well, but any components or any sub tree elements will be now aware of its surrounding, of its this context. And there's also some pitfall, especially when you use context. Always the use context. Always look for the closest provider about the components that calls it. It search aware and does not consider provider in the component from which you're calling use context. It search aware and does not consider provider in the component from which you are calling. So this is one of the pitfalls, especially here, because when you use context, it's gonna look for the provider above the component that calls it, right? So you cannot use a context at the same level of your component. It search upwards and does not consider providers in the component from which. So, and the idea of this is to now have the ability to understand how, from a bigger perspective, how these things actually works, and how now when you need to actually create your components, when you need to create components that needs to sync or communicate or control external system, there is now some built-in tools that allow you to do that. So for example, useRef, which is a way of how you can remember between re-renderings without trigger and re-rendering. And this is a secret pocket. React doesn't keep track of that. The main use case for useRef is for store the timeout ID, or to store an object, a DOM object. You want to manipulate that, or to store an object that is not involved in the GSX calculation, right? And this useRef fits on the rendering mechanism before the commit phase is initialized, and then after that is set its value. So that's why we have, for example, when you are working with the timers as a way to create as a way to build a time pass, how you can now is to get that ID from that and to actually work with that particular timeout ID reference, as well as the DOM objects, and how when you are using the timeout ID or how when you use useRef with DOM elements, usually is, for example, or to focus on input or to scroll elements, not useful, for example, to interact with. You can also do that, and there is a cost associated with that. for example, to interact with the video tag as well. Remember that when you find yourself in the need to interact with an external system, that's when effect shines, and that's why effect was designed. So to understand what effects are, we need to also look at what events are and the subtle difference. So in your React component, there are two types of logic: the rendering logic as well as the the rendering logic as well as the the rendering logic, okay, as well as the sorry, right, rendering logic, which must be pure, okay, and the event handling logic, which this is when you can perform side effects. So these side effects, which is now affects the primarily intent of, so it modify the programs, and it affects how the programs works by altering by altering is, or it is global name, or it is global state, or global variables, or data structure, or working with input and output. So when you want to, for example, connect to external system or send a request to the server, or for data fetching, you want now is to use an effect, which it will run this side effect, this code, after by it will call this code caused by a rendering itself. So the use effect fits in the rendering mechanism at the end of every render. So you might not need an effect. You might not. You might not need an effect because. You might not need an effect here. Exactly. Okay. So you might not need an effect when you need to sync an state with another state. So you don't need an state for that. So, but the idea is looking at the use effect and by looking at the use effect and how you can create an effect. So by default, you use this hook, and then we'll now run this side effect using the use effect. It will now run this side effect after every commit. So usually you don't want that. So what you do is, if you pass as a second parameter an array, or if you pass as a second argument an empty array, it will run is only when the component is mounted. Or if you want to now determine when you want to trigger this code, you pass an array of dependencies. So inside of that, you also need to define is your cleanup logic. And last but not least, your cleanup logic. So when we look at, so by looking now at the anatomy of the use effect, we can now see this. This is now the mechanism of the use effect and how the mechanism, how that works. So first is it actually enter how do you put it? Yeah. So first, how do you put it? This. Okay. So first, okay. The anatomy of the use effect. Okay. It first actually get into Jesus, the anatomy of the use effect. So the anatomy of the use effect and how that works. The anatomy is that the use effect has the setup code. Inside of that you have is the cleanup code as the first argument, and the second argument you have is the array of dependency. The mechanism is that when this component is mounted, the setup function runs. Okay. If this cause or if these components re-rendered, well, React will call the cleanup function with the old state and the old data, and then run this setup function with this new state or new values if you have an array of dependency. And they do that by using is the obj.is, this built-in function from JavaScript. And lastly, it will run now one last time the cleanup function when your component is unmounted. Because now this is the life cycle of this, all right, and how that actually works, which is exactly the life cycle of an event, which is something that we're going to see here. So once we look at that, which is part of this, so once we look at that, and also especially when you are in development mode, React now have this strict mode when they say, all right, now let me is to prevent some common gotcha, especially with states and effect, please allow me to rerun your or re-rendering your components and rerun your effect twice. All right. So that's why you have, for example, when you're running your application in dev mode, using is and you have an effect in there, you have now how that it triggers the setup, cleanup, and setup code as a way to prevent some common gotchas. And instead of you having to find a way to how to get rid of that, find a way of how you can make your effect to fit or to work with the cleanup function. So most of the time your effect will be, you will write your effect in, most of the time you will write your effect in, most of the time you will write your effect, most of the time your effect, the effect that you will write will fit into this category, or this pattern, whether it is synchronizing with non-React components or non-widgets. So for example, a map, mapbox, GL, you got is mapbox, GL, maplift, external system, okay, external widget, or triggering animations, or working with event, subscribing to events. So for example, with the window object, okay, scroll or and then you remove that scroll event listen, you unsubscribe to that. uh, Data fetching, which is something that is not trivial, pretty much like routing. And with data fetching, because there is no ability to undo a request, a network request, you just ignore that or abort the operation. And for abort, you use is a particular API, but the recommend is to ignore that. How do you do that? Well, by in your set of function, set the flag ignore to false, okay? Perform the async operation there, and when you're going to update that state, which is this, and when you're going to update that state, all right, now check if that is false. If you ignore that, if the ignore is false, good. So set that state. If the ignore is true, when you rerun this function, or when the user ID or when the array of dependency change, then please in the cleanup function ignore that previous request. This particular way of fetching data, which is something that you're going to see in development as performing twice, in production you only see a one request. There's some libraries out there that allow you to now data fetching and actually solve a particular problem with this approach. Because even though that we have now how you can fetch data, it comes with some trade-off, which is that particular code, the effect is not running on the server. It means that when the initial server HTML is sent to the client, it shows a page load or a loading state, and then the browser now fetch the JavaScript to add the interactivity, only to figuring out that now it needs to perform a network request. So that's inefficient. So you have now this duplicate requests. Okay. The other is now when a parent and a child and another child component actually make HTTP requests or fetch data, you now end up into having a waterfall networks, which of course slow down your app. And the other is caching, because anytime this component is mounted and unmounted, when this component is mounted, unmounted, and remounted, okay, you need to also again need to fetch that data, because you don't catch that. So that's why now when you're using an effect, the React docs say it's either preferable to go with a tool built from any of these frameworks, whether it's Next or Remix, or whether it's Next, Remix, or what's next one? Remix, Next.js, or Gatsby. Okay, Remix is now being used heavily by Spotify, and Remix is now being used by Spotify, and the other is yeah, by Spotify. All right. Mhm. Mhm. Exactly. one of them is for um, using this framework. Jesus, did I lose my mind? Using this framework, built-in tools, or using catching client-side libraries like React Query, which is now we know what we use in React Query because it's quite hard to actually do that. It's not trivial. Like routing, using React Query or SWC, I think it's that. Use SWR, which is stale while revalidate data, which is another way of how you can render your applications. Okay. SWR is created by the same team behind Next.js, the React framework. Okay. And they provide now this React hook for data fetching. Again, it's because this particular use case that are fairly common and quite complex. All right. So now we understand that lightweight, real-time, suspense, pagination, backend agnostic, single server-side rendering, and static site generation ready, TypeScript ready, remote and local. It's a stale while revalidate, an HTTP catch invalidation strategy, an HTTP catch invalidation strategy popularized by this. SWE is a strategy it's a strategy to first return the data from catch. Okay, it's a strategy to first return the data from catch, stale, then send the fetch request, revalidate, and finally come up with updated data. Stale, stale is old. Stale means old. Okay, stale. Exactly, old. Stale. So stale, or fetch this data from the catch, from the stale, then send the fetch request, revalidate, and finally come up with up-to-date data. This is a HTTP catch invalidation in strategy, popularized by this. So the idea here is to know this mechanism and how this mechanism also allow us to build this now applications, bring UI interactivity to the web, and therefore improve the user experience, improve the product, increase the sales, and our margins. Interesting, very, very interesting, very, very interesting. Okay, so that's the entire reason why we're doing is this. Okay, and why we actually, when it comes to data fetching, we usually, and the other point is to raise condition. So this raise condition is something that you're gonna suffer, especially when you, on the client side, you actually send a request several times. Okay, so to prevent all of this, React docs say it's preferably to go with any of these framework that they already have a built-in mechanism that is very good at what they're doing, data fetching, Remix. Okay, Remix, Next or Gatsby, or use this client-side catch or build your own. Whether it's React Query, use SWR, use SWR and React Router. If you're going to build your own, it needs to deal with deduplicating requests, which means that since this side effects won't run on the server, it means that the initial server side HTML will come with the loading state, and then now the client needs to fetch that data or to fetch that JavaScript, only to figuring out that now it needs to perform an HTTP request. So you need to deduplicate that request, the duplicate request. You need to catch that response, and also avoid is waterfall, avoid network waterfall and race conditions. If you're up to the task, go ahead, man. Go ahead. The, where I donate, man? Where do I need to donate that? In any case, the other is sending analytics, and for analytics, you say, hey, it's going to have a now. We need to build our app environment driven, which means is that on the development, we're not going to trigger or we're not going to send analytics. On the staging, we do, as well as on production. Okay. And now when it comes to say, hey, you might not need an effect in your components, this is when things get a little bit interesting. Why is that? Because now we are going to the finicky, into the weeds of this. Okay. So now we're going into the weeds. We're getting into weeds. We're getting into the weeds, right? About when we don't need an effect and how we can now combine all of that as a way to say, all right, now that'll work. Actually, this is what it needs to be done. All right. So usually, because if you're computing of your so you don't need an effect to transform data for rendering. So computing data from that, and the dimension is this. For example, let's say you want to filter a list before displaying. If you want to filter a list before displaying, you might feel tempted to write an effect that updates the state when the list changed. Why this is inefficient? Because when you update the state, React will first call the component to calculate. We'll call that component to calculate what should render on the screen. Then React will commit this change to the DOM, updating the screen, only to realize that now when it comes to run this effect after every commit, you are also is setting a state. You are updating a state, and this restores the whole process from the scratch. This is to avoid the unnecessary render pass. You know, so transform all the data at the top level of your components. That code will automatically rerun whenever your prop or state changed. So whenever your prop or state changes, that code will run, all right, in your rendering logic. So please, if you need to find, if you need to transform data for rendering, don't use an effect. Okay, it might be tempting, but the problem is that you're creating is a loop. That's what happened. And the other is that you don't need effect to handle user event. Okay, you don't need effect to handle user events. Exactly. So for that, use an event handler for this. Again, this is the two more common cases which you don't need an effect. Transforming data for rendering? No. Put that logic into the rendering logic, or therefore in your top level, transform all data at the top level of your component. When you mean that, transform all data at the top level of your component. What does it mean, this? Exactly. When they say the top level of your component, okay, transform all the data at the top level of your components. Transform all data at the top level of your component. This code will automatically rerun whenever your props or state change. Transform all data, suggesting processing or formatting your data before passing it down to child component. Exactly, but when they say top level data or top level of your okay, this is what they mean. What say for transform data for rendering, transfer all the data at the top of the level, at the top level of your component. And that code will automatically rerun when your props or state change. You can also, if you find yourself needing to compute a particular state during rendering, you can do that as well. But when it comes to transform data for rendering, for example, a list, do that in the top level of your components, and then share that props and then share that across other components. You don't need effect to handle user events. In this case, for example, performing a task. So you do need an effect to synchronize with external system. For example, you can write an effect that keeps a jQuery widget synchronized. So for example, a no. So for example, a jQuery widget synchronized with your React state. Mm-hmm. 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 So for example, you can write an effect that keeps a jQuery widget. So for example, weather, or and most of the time is weather, time, or let's say map. Okay. Keep in mind that modern framework provide a more efficient built-in data fetching mechanism that writing effect directly in your components. So to help you gain the right intuition, let's take a look at some common concrete examples to help you right to help you get the right intuition. Because exactly it's like that. It's like this. Update state based on props or exactly update state based on props or state. Do not use an effect. Compute that during rendering. Catching response or catching expensive conditions or calculation. Use Memo for that as a way to say, hey, I want you to now return this computation, or I want to catch these computations between re-rendering, and only provide that when the array of dependency change. And when that change, well, by using is the object.is, which is a built-in function from the object JavaScript. That has that resetting all state when a prompt change. Use the key for that in your components, and you want to restore that. Adjusting some state when a prop change, again compute that for that. So if you want to adjust some state when a prop change, so for example here, sometimes you want to reset or adjust a part of a state on a prop change, but not all of it. Okay, if you want to adjust a part, if you want to reset or adjust a part of the state, okay. The list component receives a list of items as a props and maintain the select items in the selection state variable. Okay, this list component receives a list of items as props and maintains the selected items in the selection state variable. You want you want to reset the selection to null wherever the items props receive a differing array. So instead of actually using an effect for that, all right, what you can do is to define a selected ID, especially when you have now this selection pattern. Use the ID here, okay, as a way to calculate where you at. As a way to calculate where you at. So this is not this too is not ideal. Every time the item change, the list and the list component will render with a stale selection value at first. Then React will update the DOM and run the effect. Finally, the select null will cause another re-render. This is causing another re-rendering here. Okay, especially when the items change. So your effect that you are creating is a loop. So you break your browser. So start by deleting the effect and instead adjust the state directly during rendering, which is, hey, you get the previous item, okay? If the items is different from the previous item, this is another thing that you can do. Set the previous item for that. Storing information from previous renders like this can be hard to understand, but it's better than updating the same state in an effect. In the above example, set selection is called directly during rendering. Exactly. React will re-render a list immediately after it exits with the return statement. React has not to render the list children or update the DOM yet. So this let children skip renderings the stale selection value. When you update a component during rendering, React throw away a GSX. Exactly. When you update a component during rendering, React throw away the returning GSX and immediately retries rendering. To avoid very slow cascading retries, React only lets you update the same component states during a render. React only lets you update the same component state during a render. If you update another component, okay, React only lets you update the same component state during a render. If you update another component state during a render, you will see an error. A condition like items is different to the previous items is necessary to avoid loops. You might adjust state like this, but any other side effects like changing the DOM or setting timeouts should state in the event handlers or effect to keep components pure. Okay, it's because this is the way. Okay, because React only let you update the same component state during a rendering. The same component state during a rendering. If you update another component state during a render, you will see an error. A condition like this is necessary to avoid loops. Okay. A condition like this is necessary to avoid loops. Although this pattern is more efficient than an effect, most components shouldn't need it either. No matter how you do it, adjusting state based on props or an state makes your data flow more difficult. Exactly. Adjusting state based on props and other state makes your data flow more difficult to understand and debug. Always check whether you can reset the state with a key or calculate everything during rendering instead. For example, instead of storing and resetting the select item, you can store the select item ID. But this is something that they mention here, especially when you are adjusting some state when a prop change. You can is either reset all state with a key or calculate everything during rendering. Especially when you want to reset. Okay. Especially when you want to reset a state. Or when you want to update or adjust in some states when a prop change. Updating. Okay. Calculate that. Calculate all of the states during rendering, or reset the state from that. So in this case, what you're doing is to calculate everything during rendering. Now there is no need to adjust the state at all. If the item, exactly, if the items with the selected ID is in the list, it remains selected. If it's not, the selected calculated during rendering will be null because no matching item was found. This behavior is different but arguably better because most chains to items preserve the selection. So instead of actually adjusting some state when a prop changes, you either reset all state with a key or calculate everything during rendering. Holy moly. Okay, when you want to reset the state, you have now two particular way of resetting the state. Whether it's adding a key to the component or calculate everything during rendering. Sharing logic between event handlers. Let's say you have a problem. Okay, sharing logic between handlers, especially this. When you're not sure whether some code should be in an effect or in an event handler, ask yourself why this code needs to run. Use effect only for code that should run because the component was displayed to the user. So that'll be all for this video. Take care. Bye bye.